Hi guys, today let us study about the concept of moment of inertia. Well, first moment of area. When dealing with the center of gravity and the centroid, we take the moment of area into the consideration. So, what is this moment of area? This is nothing but the product of the area and its perpendicular distance. Hence, the first moment of area will be given by A into x, where A is the area and x is the perpendicular distance. Now, what is moment of inertia? Well, if the moment of area is once again multiplied by the same perpendicular distance, that is x, then the product of this is called as moment of inertia, or also called as second moment of area. Hence, moment of inertia will be given by ax into x, which will be ax square.
Now let us find the moment of inertia of a plane lamina by the method of integration. Well, consider a plane lamina whose moment of inertia is to be found about the x-axis and the y-axis. Now, divide the whole area of the lamina into a number of strips. Consider one small strip, say having an area of dA. Now, let x and y be the distance of the center of gravity from the x-axis and the y-axis respectively. Now, moment of inertia of strip about the y-y axis is given by dA into x square, that is the product of the area into the square of the perpendicular distance. Similarly, the moment of inertia of the strip about the x-axis is given by dA y square, that is the product of the area and the square of the perpendicular distance. Now, these are the moment of inertia for a small part of the lamina. Hence, the moment of inertia for the whole lamina will be given by, that is the moment of inertia about the y-axis Iyy is equal to integral of the mi of the strip about the y-y axis, that is dAx square, which will be equal to summation dAx square. Similarly, the moment of inertia about the x-axis for the whole lamina is given by Ixx is equal to integral of dy square, that is nothing but summation of dy square.
Next, the polar moment of inertia. Well, this is nothing but the moment of inertia of an area about an axis which is perpendicular to its plane. Hence, the polar moment of inertia Izz will be given as the sum of the moment of inertia around the x-axis and the moment of inertia about the y-axis, that is Ixx plus Iyy. This is similar to something called as the perpendicular axis theorem, and its proof will be studied in the later videos. Next, we move on to the concept of product of inertia. Well, product of inertia is nothing but the summation of the product of each elemental area, say dA, its perpendicular distances from the two reference perpendicular axes, say x and y. Hence, this is denoted by I into xy. The product of inertia can either be positive or also can be negative. Hence, considering the following figure, we have the product of inertia of the whole lamina will be given by Ixy is equal to integral of dA into xy. Next, radius of gyration. Well, radius of gyration is the distance from the reference axis where the whole area of the body is assumed to be concentrated such that this does not alter the moment of inertia about the reference axis. The radius of gyration k is given by root of I divided by a, where I is the moment of inertia about the reference axis divided by the area of the object. Hence, radius of gyration around x-axis kxx is given by root of Ixx divided by a, and the radius of gyration about y-axis kyy is given as root of Iyy divided by a. Also, the polar radius of gyration, that is kp, is given by root of Izz divided by a. Thank you.
Wow, that's That's impressive! You have completed a magic today. For more videos, subscribe. Join our Facebook group and Instagram page for group discussion and live magazine videos for exam preparation in an hour. We start at ClassFly community for students to learn from a friend in a simple way and support them in their own languages. If you are willing to be that one friend who saves us at the exam night preparation, then please join us by visiting classfly.in.